So let's look at some technologies here that is current. We're actually going to look at something that is already there and where it might go. First of all, I want to speak about the BIM model in the cloud. This is something that is out there today. A lot of companies, Vela, Autodesk, Tekla, are building huge computer bases in the cloud with parameters to handle a project. And now they're trying to figure out a way how to design directly in the cloud. So in the middle here, I'm going to put a database. And this is not a 3D model, don't get me wrong. This is like an Excel sheet which describes the house in numbers, right? Understand? Because if you have an Excel sheet, it can never get old. One is always one today in 100 years, but a 3D model has a version or a technology behind it. A number is always a number. So if you look a little deeper to the database, which kind of looks like a house, there's no files. Everything you make when you make an addition is saved instantly. You can also roll back the project in time. You have a 4D slider. You know, this is actually done today. There's nothing new about it. It's been done for ages in the car industry, and now it's getting to the building industry. How about that? 10 years later. So that you won't be sending files today. There's a lot of people working with IFC file formats. The standard is good, but you're not going to send files anymore. Every time you send a file, you have to do conversion work, 8-9 hours for conversion. Nobody wants to pay for that anymore. The second one is this is, for example, how you can describe a wall and a door. The project is 100% numeric. When you build a project today, you have to build it in a sheet. And the most important part about any BIM cloud project is the column to the right, the GUID. The GUID is a global unified identifier, and this is a name on a 3D object. This name is 100% unique. If every person on the world would make 600 million randomized numbers, they will not even hit the chance of having two exactly the same. It's very unique. It's like a universal unique identification tag. This tag will follow the object from the drawing board all the way through the building and into the management phase. So everything in the future is going to be about GUIDs. Today when you work in AutoCAD, when you work in Vico, when you work in Rhino, when you work in Revit, every 3D object has a GUID attached to it automatically. You can find it in the API, you can find it anywhere. And as long as you keep this number intact through the whole process, you can look on the internet and you can actually position where is the wall. Is it in my computer or is it on the way on the trolley to the building site? This is a very important thing. It can never be overwritten, it should always be the same. This is done today and it's going to be even bigger. So what you do instead of sending a 3D model, you're sending information. To the left here we have a 3D model which is blue, and we have a little blue point which is the starting points, X, Y, Z. I have a GUID which says this is the identification of the object, and I have the standards of describing the project. I send information to a computer base, and I have the same GUID on the other side, I have the same coordinates, and I can start synchronizing, right? If I just send the coordinates, I'm synchronizing two objects, just by synchronizing. It's not magic, it's pretty simple. This means that I can actually skip the file formats. I can have Revit on one side, I can have whatever Rhino on the other side, and I can start sending 3D objects without sending files. I can work in the cloud, I can work with the GUID. Change the door, you can go to another door supplier, he changed the sheet, but the GUID remains the same. You see the idea here? No 3D geometry is going anywhere. We can talk more about this later. So, if we have this with us, we can also let the computer base start communicating. The computer base also, the BIM computer base has all the users connecting to each other. Just the same thing as you log on to Facebook. You have a chat board. You're also sending out who owns what 3D model, what should it be doing. The house is communicating with the user, or maybe the house is talking to each other. In the future, if it's a hurricane in Los Angeles, it will tell the house next to it, so they can, the house itself can adapt and close shutters and stuff like that. We will have dynamic houses in the future. Architecture will be a living system, and then we talk to each other with a computer base in BIM, right? Simple, isn't it?
But is there a physical file that is actually saved in the cloud?
Yeah, locally, and this file is like a photograph. It's generated it's like a stream, right? You know, RSS feed. So you're actually subscribing to the 3D model. How about that? That's pretty neat. And that can be done today. That's not needed in the future. Just that nobody has done it yet, pretty much. Yeah. And of course, we have the unlimited cloud power. This is a picture of Google's server hall. And when you're making a software today in the cloud, you're actually telling the software to have a free power. If you need more, you just add a couple of more processors. So there is projects for they're working with DNA. They're having 100,000 processors working at the same time. So if you have a big project here, while it is connected to the cloud, you can really start spinning around big projects, right? So this huge computer there's never a performance issue. You never have to have any software. You never have to have any drivers. Just log on, start drawing, and that's it. How about that? Okay. So now we have the center in the future BIM, the core here made up. So on the right and the left side, I have two different interfaces. I have the virtual project and I have the in real life project. We're going to have a virtual project on one side and the real building site on the other side, and it's going to be synchronized. And to be too synchronized, it has to be an API, like a translator between the cloud and the software. I won't get too technical, we can do that some other day, but I want to show the concept here. And if we look at the virtual project, it's going to come to this. Anybody can be a designer. You can sit anywhere in the world to do on any computer. In the future, you will take your little Android telephone and you will start designing a skyscraper sitting on the mountaintop in Tibet, if you have internet connection, or offline, I don't know how you do it, but this is really interesting. We have cases today where people are designing without being architects. There's going to be young people designing the dream houses, and there's going to be an engineer sitting in China to do dimension, and it's going to be another one, an acoustic guy sitting in America, working in real time with this 19-year-old designing the house in the cloud, simultaneously in real time. The technology is actually right here, right now. It's going to happen one way or another. The beauty of this is you can start combining 3D models how you want. In this case, I have three identical 3D models in three different software. For example, Revit, ArchiCAD, and the little yellow dot there, or the green dot, are interfaces speaking to the computer base in real time. And then the third person is sitting with a web interface and controlling both models, independent from the program, with their own interface, right? Then again, you don't need to have a software. The third person can also be a computer helping out. We are now looking to experiments with auto dimension, auto construction, auto ventilation. It's coming in right now. Just draw a house, press generate ventilation, and it's going to be done. It's kind of neat as well. And when you work with the project, you're going to get your portion of the data at the right amount of time. If you're sitting in the specific phase in the project, here is your data right now, here are you plan for, nothing else is yours. You only get plan for, and you only get this amount of parameters. You work with them, you put it back up in the cloud. And somebody else over here is going to have plan 6 and a different set of parameters. And when you're going to draw the house, there's going to be a big sign at the top that says, your house is costing 1,268,000. I move on, it's going to cost 1,269,000. It's going to be a live price in the project. This also going to says it's going to take you 6 days and 2 weeks to make the house. I do another door, it's going to take 7 weeks and 8 doors. Think about that when you do a kitchen renovation at home. How about that? That would be something, right? And again, this is an emerging technology. It's already out there, but we're going to see it in our branch. It's all about beam data. It's all about parameters. This is your own custom filtered parameters. Is the English working fine, or should I switch to Skånska? No? No? Nobody? Okay. And of course, as I said before, real-time simulation and auto-parameter. Today we're working with green projects. Some of you have been working with Green Studio, for example, or we're looking at simulation computer bases. We can do Vasari, Ecotex simulations. I don't know if you use them. It's actually a big service in America, putting in climate data and real-time to your projects. We're going to see the same thing in construction, in electricity. You're going to have somebody looking over the shoulder to pretty much dimension your house as you do it. We don't need the engineer in the future.